So let's look at the problem number 1 now. We have 3 times 7 to the x equals 98. So we'll first apply division by 3 for both sides. So I have 7 to the x equals 98 over 3. At this point, I will apply the log to both sides. So I'll do log here and log here. And I need to put parentheses around here and 7 to the x or 7 to the x. Applying the power properties of logs, we could have put the x out in front. So we have x log of 7 equals log of 98 divided by 3. In order to get x by itself, we want to divide both sides by the log of 7. So we end up with x equal to log of 98 over 3 divided by the log of 7. We're now ready to punch it into our calculator. So I punch in log. It automatically does an open parentheses. That's 98 divided by 3. If I then press divided by log of 7, I'm not in the right place. That would be like putting the log 7 inside of here. I want it after that, so I need to make sure I close the parentheses. Then divide by log of 7. When I press enter, I get 1.7916. We'll chop that off as 1.79. Next, we're going to switch over to problem number 3. So here on problem number 3, we have 2 to the x minus 4 equals 5. So the first thing I'll do is add 4 to both sides. So I have 2 to the x equals 109. At this point, I'll take the log of both sides. So I have log of 2 to the x, log of 109. Applying the power properties, I get x log of 2 equals log of 109. I probably should put parentheses around that one. To get x by itself, divide by log 2 again. So when I punch that into the calculator, I should do log of 109. Don't hit the divide sign now because it's inside that parentheses. I need to arrow back and close that and do divided by log of 2. It automatically closes it if you hit the equal at the end, but I can put it in there just to be on the safe side. 6.76 will have me end up rounding off as to 6.77. The next problem I will show is problem number 6 right here. So we've got a whole bunch of stuff going on here, and there's a whole bunch of things in this inside this parentheses. I could reduce this down by doing 1 plus 0.02 divided by 12 and just putting the decimal that shows, but when I do that I get a really long decimal. And I'd rather not lose some of the pieces of the decimal until later. So I'll keep it like this and just punch all that into my calculator. You just have to be careful with your parentheses. First step is divide these both sides by 250,000. 500,000 divided by 250,000 is 2. Ooh, that was a big old number. So I have this thing right here. 1 plus 0.02 over 12 to the 12t. Obviously, this was something like somebody had $250,000 in their account. They're getting 2% interest compounded monthly. At what point will they double their money? So here we go. I'm trying to solve for t, time in number of years, usually. So I'll take the log of both sides. Log 2 equals log of this. If I then apply the power property, this 12t will come out front. So at this point, I would have log of 2 equals 12t times log of 1 plus 0.02 over 12. To start getting t by itself, I'll divide both sides by the log of this thing here. So on this side, I'll have log of 2 over log of this stuff here. 1 plus 0.02 divided by 12 is equal to 12t. The last step I'm going to have to do is divide everything by 12. So what I'm going to do is I'm just going to cross it off here, and I'm going to write divided by 12. So this is what I'm going to punch into my calculator, divided by 12. So I have log of 2, close the parentheses, divided by log 1 plus 0.02 divided by 12. It will follow the correct order of operations. So 1 plus 0.02 divided by 12. There's the log of 1 plus 0.02 divided by 12. Close parentheses. And then I will divide by 12. I can punch all that in now. There's my division by 12 at the very end, equals 34.686. So the time would be 34.69, and that's usually in years if this were something like interest compounded 12 times a year.